Hello, Math Humans. We're going to do 8.2a today. We're going to be talking about matrix operations. Specifically, we're going to be talking about, we're going to do math, but we're going to be talking about adding and subtracting matrices and then a scalar multiplier. So for matrix addition and subtraction, the thing that is the most important is that the matrices are the same size. So the dimensions of the different matrices that you are going to add and subtract together have to be the same size. So let's just start out with an example. And so the directions are do math. Woohoo, that's easy. So let's say I have negative 1, 2, 0, 1 added to 1, 3, negative 1, 2. Well, when I add matrices together, notice these are the same size, they're 2 by 2s, but like elements are added together. So this is a negative 1 plus 1, and then it would be 2 plus 3, and 0 minus 1, and 1 plus 2. So the sum of those two matrices would be 0, 5, negative 1, 3. Okay? And if we called that matrix A and matrix B, we would identify by saying that that was A plus B. Okay? For our second example, we're going to do subtraction, and subtraction is just the same thing as addition, right? But now we're adding negative quantities. So let's say I had negative 1, 2, 0, 1, same matrices, and I want to subtract them, 1, 3, negative 1, 2. You just have to remember that the negative is distributed to every term inside the matrix. So it is, for our solution, if I did A minus B, it's going to be a negative 1 minus 1, 2 minus 3, 0 plus 1, because a negative and a negative is a positive, 1 minus 2, and so this is negative 2, negative 1, 1, negative 1, and that would be our matrix A minus B. So it's really pretty easy. The next topic that we want to talk about are scalars, and if you will remember from geometry, to going back into the deep, dark recesses of your math brains, remember that a scalar was how something changed size. Okay, so I can either get something bigger or I can make something smaller. Well, the same thing is true with matrices. So if I had a 3 outside of matrix A, B, C, D, then that's going to make matrix A, we'll call him matrix A 3 times larger. And just like when we did our subtraction up here, this 3 is going to magnify every element on the inside of the matrix. If I had a 1/2 times A, B, C, and D, then that is going to make matrix A 1/2 as large, which means it is going to shrink. Okay? So if it's a number greater than 1, it's going to increase the size of the matrix. If it is a number less than 1, right, and we're talking about the absolute value of the number, not the positive or the negative, it's going to shrink the particular matrix. All right, matrices are just math, and so they have properties just as math does. So properties of our matrices. I'm sorry, I am hoarse. It is the end of the day, and that means I'm hoarse. So if I have matrix A, and I add it to matrix B, that's the same thing as matrix B added to matrix A, and that is the commutative property. And if I have matrix A added to B plus C, that's the same thing as A plus B plus C. This is the associative. Okay. And then if I have C and D times A, and notice the notation, remember that we always talk about matrices with capital letters And so these would be some scalars. So this would be C and D times A. This is also associative because I'm just grouping a little bit differently. And then if I have C times B plus A, then this is C times B plus C times A. Oops, I guess I don't need that parentheses. And this is the distributive property. Okay? So now when we do our next example, so example number 3, I'm going to solve, and it's actually your last example, solve matrix equations. Okay? So we're going to have A is equal to 1, 0, negative 2, 3, and B is going to equal negative 3, 2, 4, and 1. So my directions are going to say solve for x, okay, and my matrix equation is going to be 3x plus a equals b. And I would do the arithmetic with the equation first, or I guess I should say the algebra, and then I would bring in my matrices. So 3x is going to equal b minus a, and x is going to equal 1/3 times b minus a. And so then I'm going to set this math up, okay? So x is going to equal 1/3, and then I'm going to write b, so negative 3, 4, 2, 1, minus matrix A, which is 1, negative 2, 0, 3. And because I have nested parentheses, I'm going to do the math on the inside first. A negative 3 minus 1 is a negative 4. 4 plus 2 is 6. 2 minus 0 is 2, and 1 minus 3 is a negative 2. And now I'm going to manage the scalar, so x is going to equal a negative 4/3, 6/3, 2/3, and a negative 2/3. And the only thing that I would say is we would rewrite this term as a 2 because 6 divided by 3 is 2. And so then I would write my final product, and this is negative 4, 3, 2, 2/3, and a negative 2/3, and then we're done. You can't see it. Now we're done. Alrighty, so that is it for today. Nice short video again. I will see you soon.